All right, this is the remainder of the 3.4 notes that we kind of skipped through in class. We did kind of one of each type. So I'm going to go through and do the remainder of the problems that we had. Starting with example 2, which was very similar to example 1. Because example 2 is a rational, essentially rational means that there are x's in the denominator for us, function, that means that we can't let the denominator be equal to 0. So when we state the domain, we need to take into effect that 3 cannot be part of our domain. So x minus 3 cannot equal 0, which means x cannot equal 3. In interval notation, if we wanted to write this in interval notation for the domain, this would be negative infinity to 3 union with 3 to infinity. What that means is that's the only number that gets skipped on the number line. To do the evaluations, we just plug in the numbers for x. So f of negative 2 is negative 2 over negative 2 minus 3, which would be negative 2 over negative 5, or positive 2/5. Remember, that does make an ordered pair of negative 2, this is what I plugged in, and 2/5 is what comes out. F of 0 would be 0 over 0 minus 3. That's 0 divided by negative 3, which is just 0. F of 3, I don't even need to work out. I can go ahead and write that as undefined because I know it's not part of my domain. But if you did try to work it out, you'd notice you get 0 in the denominator. So that is why it is undefined. Okay, for example 3, there were a few more of these that I needed to do. We did one of them in class. This is doing evaluations of letters or combinations of letters into a function. For example, for this first one, if I wanted to do f of a, which is the first thing listed in my group up here, I just replace all of the x's with a's. So that becomes this. F of negative a, which is the second one we want to do, would be 3 minus 4 times negative a. This time this needs to be worked out, so that actually changes that to plus 4a. And then negative f of a is negative times f of a. So this was f of a, and this is a negative 1 out front of that, because that's essentially what we think of this as. Negative 1 times f of a. So this would be negative 3 plus 4a. The next one is f of a plus h, where we're actually plugging in a binomial for an x. So 3 minus 4 times a plus h in parentheses, because it's going in for the entire x. So this needs to be distributed. This would be 3 minus 4a minus 4h. Then we have f of a plus f of h, which means we do two separate evaluations and then add them together. The first one, f of a, we've already done, 3 minus 4a. The second one is identical, except it's now 4 times h instead of an a. And then we can combine the 3's together. So 3 and 3 is 6. Then we would still have a minus 4a and a minus 4h. Now this final evaluation here is a combination of two of the ones we already did, f of a plus h and negative f of a. This is called the difference quotient. Essentially, these two pieces go on top and they're divided by h. So f of a plus h minus f of a over h is f of a plus h was 3 minus 4a minus 4h. Negative f of a was negative 3 plus 4a all over h. The 3's cancel out, as do the 4a's. So we're left with negative 4h over h, which reduces down to just negative 4. We did b in class, so we're going to look at c. Now c is a little bit more complex because not only does it have an x squared, but it also has an x. So we start with f of a, which is 2a squared plus 3a minus 7. Nothing really interesting going on there. The second one is f of negative a, which means we change these to negative a's, which does mean you want to put them in parentheses. Negative a times negative a is actually positive a squared, so notice this term doesn't really change because it's being squared. But a positive 3 times a negative a is actually a negative 3a. So notice there is a slight subtle difference. There's a middle term that got changed to the opposite sign. Then we had negative f of a, which means you put a -1 out front of the first answer, which was just f of a. So all of those are going to change signs. So that would be -2a squared minus 3a plus 7. Okay, here's where things get a little complicated. A plus h, because you're going to have to square something, you're going to have to FOIL. And remember, the a plus h goes in anywhere you used to have an x. So you get these binomials where there used to be an x. So for this one, we'd have to write a plus h times a plus h. We'll have to FOIL that out. We can go ahead and distribute this one. That'd be 3a plus 3h, bring down the minus 7. I'm going to FOIL out these a plus h's. A times a is a squared. You get one AH and another AH when you multiply the middles, and then you get an H squared. Final step will be to distribute that 2 up front and then see if there's any like terms. So that's 2a squared plus 2 times 2 would be 4 AH's plus 2h squared plus 3a plus 3h minus 7. No like terms. Then we have f of a plus f of h, which is essentially just the first one plus one that's very identical to it but with h's. And then we look for like terms, which seems to be the only thing is like is the -7s. So 2a squared plus 3a plus 2h squared plus 3h minus 14. And then finally, remember a combination of two of the ones we already did. The difference quotient is f of a plus h minus f of a all over h. So the f of a plus h was pretty long. That was 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 7. And then we have to add this on to the end. So that's -2a squared, -3a, and plus 7. Sorry, I ran out of room, all over h. The 2a squareds are gone, the -3a's are gone, and the +3a, and the -7 and +7 are gone. That leaves me with a 4ah, a plus 2h squared, and a 3h. Okay. So then when we look at pulling out an h on all of these, because this is all over h still, that'd be 4a plus 2h plus 3 all over that, and the h's will cancel. So my final answer will be 4a plus 2h plus 3. All right, so it's not much different than plugging in numbers, but because you're dealing with variables, you have to deal with properties of like terms and distributing. So that's the big difference. Okay, we looked at some of the graphing techniques. We defined what is a function by the vertical line test in class. We did one of example 5, but I believe we did not do B in both classes, so I'll do B again. So it says determine the domain and range of the picture below, and then determine the value of f of 1 and find all x's such that f of x equals 1. So for this first one, I'm going to mark off on the x-axis, where does this start and end? So for the domain, I start at -5 and I end at 7. Those are my x values. That's how far on the x-axis this graph stretches. For the range, you look at how big or small the y values get. So from -1 for y up to +2. That's my stretch vertically. F of 1 means if this is x, what is y? So go to 1 for the x, find the y value that's attached to that. So that's 1 will give you an output of -1. The last question is a little bit trickier. It says find all x's such that f of x equals 1. This means you already have y, you are looking for x. Now with this, it can be more than one answer. In fact, you just kind of think of a horizontal line through that height of 1, and anytime you cross your graph, there's an x that works. So the x's that work are -3, because that's this point, -1 for x, 3, and 5. All of those x values have a y value of 1. Okay, for number 6, we did almost all of these in class. I saved one for the video. If you're trying to find the domain of a function from the equation, you have to look for some key things. First of all, are there x's in the denominator, and are there square roots? Those are the two big ones that we've encountered so far. This has both situations. When there is a square root, so this is an even root, square root is even, you need to keep this greater than or equal to 0. But in this scenario, you can't just be equal to 0 because you already have this in the denominator. Because this is in the denominator, you don't want to be equal to 0, you just want to be greater than 0. So the first thing I'm going to do is see what would make that greater than 0. And it looks like if x stays bigger than -3. So I usually come over here and just kind of think about what that would look like. Okay, so not -3, but bigger. So it's not a closed circle, it's an open circle because we don't want to equal 0 in the denominator. The other thing we have is that +3 would also cause a problem because of this x. So somewhere over here is +3, so we need another open circle. And then keep shading. So in interval notation, this would look like -3 to 3, both being open since those are unusable values, unioned with 3 to infinity. So that would be my domain. Okay, we talked about increasing, decreasing, and constant in class. I did one of these. I'm going to do the other graphs that are remaining. So looking at this first one right here, we can graph this just using, because it's a line, this is y equals essentially. So +3 is my y-intercept, and my slope is -2/1. So I can go down to right 1, or I could go up to left 1. So there's my graph. It looks like it crosses the x-axis at 2, but we can double check that. It doesn't. That's probably not an accurate picture. If we want to find, it doesn't ask me to find that, but if you want to find it, you can plug in 0 for y and solve for x. It's actually going to be probably 1.5 is what it looks like. So I need to find that domain and range. With lines, there's not really much interesting going on. A line can have any x you want plugged in, and lines go up and down forever. So essentially, if you have a line that has got a slanted slope, like we do here, it's all real numbers for both. When we have increasing, decreasing, or constant, that on a line, that's just going to be one of those. And in fact, we are decreasing forever. So we are decreasing on our entire domain. So -infinity to infinity. We did B in class, so I'm going to look at C and D. To get a graph for C, you have to first of all make sure you're in the correct domain. So we have to stay greater than or equal to 0. We would subtract over the 4 and then divide by -1. Because we're dividing by -1, we have to keep that sign in the middle flipped so it becomes less than or equal. So my domain looks like anything smaller than 4. So we know that before we even graph it. So I'm going to do a little table. So 4, 3, 2, 1, 0. I don't know how many of those points will be good, but we'll just try. I like to get perfect squares. So square root of 4 minus 4 is square root of 0, which is just 0. 4 minus 3 would be square root of 1. Square root of 1 is 1. I don't think I'm going to use 4 minus 2 because that's square root of 2. 4 minus 1 is square root of 3. That's not a perfect square. But 4 minus 0 is square root of 4, which is going to be 2. So 4, 0, 3, 1, and 0, 2. Those are my points. Notice now I can pick out the range. This has the lowest y value that we get is a 0, because notice we never cross below the 0 line here for 0. So this would be from 0 is my smallest value, and this is not getting big fast, but it is continually getting bigger. So it eventually gets up in the big values to infinity. And then this is also decreasing. How you can tell is if you go from left to right, are you going uphill or downhill? This is completely a downward slide. So this would be decreasing on its entire domain. Now we don't use a bracket on increasing, decreasing, and constant. I know WebAssign sometimes does. They really shouldn't, because you are not able to decrease on a singular point. You decrease over an interval. So if they used a bracket, they use a bracket, but you really shouldn't. And then the final graph is actually kind of a tricky one. Oh, sorry, this one was supposed to be marked out. Y equals 3, because this is just y. This is a horizontal line. Now these are special lines because they don't actually use the whole real numbers for their range. They do for their domain. I can still plug any number in I want because there's no x here, but I can still plug a number in and it's just going to give me 3 always. Your range is a singular value. You only ever get the height of 3. And this would be constant on its entire domain, so negative infinity to infinity. E should not have showed up on y'all's notes. If it did, make sure you mark that one out. Okay, so we already formally did the difference quotient. This is just showing you how it's related to calculus, and that if you have two ordered pairs where there's a distance of h between the 2 points on the x-axis, so notice a and a plus h, that's a secant line. So if you use the if you do the slope formula here, you're going to find the slope of the secant. In calculus, you eventually shrink the distance between these 2 points until you become 1 point, which then gives you the slope of something called the tangent line. But for us, we're just doing the slope of the secant line, essentially. That's our difference quotient. So we're going to do just one more of these, just showing you, and this time instead of using the letter A, they're using X, because that's typically how it shows up in a textbook. So because this is what we're trying to find, I'm going to do what we did before. I'm going to find f of x plus h, and I'm going to find negative f of x. If you can find those two things, you can plug them into the top of this. So remember, when you do x plus h, you're plugging it in for the x spot. So that means it's going to have to be written twice because it's squared. So that would be negative 2 times x squared plus 2xh plus h squared. If I FOILed that out and combine the middle terms, and then I need to distribute my negative 2. So that would be negative 4xh in the middle. And then negative 2h squared plus 3. So that is my first part. Just going to highlight that for right now. So that's that. To find negative f of x, you just put a negative sign in front of the whole thing. Essentially, you multiply by negative 1. So that makes that 2x squared minus 3. Notice this and this correlate with that. So then all I take is yellow and blue and put them on top over h. So negative 2x squared minus 4xh minus 2h squared plus 3 plus 2x squared minus 3 all over h. If you've done this correctly, some things should cancel out. And we're left with negative 4xh minus 2h squared over h. And then canceling out the h's, one on each part, you get negative 4x minus 2h. All right, and the very last thing in section 3.4, we didn't specifically do this one in class, but we did it in the previous section. This is essentially 3.3. So if you have y equals mx plus b, which they're calling it a little different here, notice f of x equals ax plus b, still a linear equation. You should still be able to find a linear function. A linear function means that you still find y equals mx plus b, but at the end, instead of writing y equals, you write f of x equals. The difference is how they present this. So this is actually, remember, an ordered pair. That's an x and a y. So if it helps, rewrite those as ordered pairs. Now you know you're just finding a slope because you want the equation. So this is negative 2 minus 7 over 4 minus negative 2, plus on that one. So that's negative 9 over 6, which is negative 3 halves. Then we would use our y minus, and pick just one of the points, so say I pick this one, y minus 7 equals negative 3 halves x minus negative 2, which is going to be plus 2. I would multiply both sides by 2 to get rid of that denominator. So multiply both sides by 2. This would then be 2y minus 14 equals negative 3x minus 6. Add the 14 over. That would be 2y equals negative 3x plus 8. Divide everything by 2. And then the final step is to change this to an f of x. So f of x equals negative 3/2 x plus 4. So nothing new here really except just how it's presented. If you need a linear function and you need f of x, usually they'll still give you two ordered pairs even if they give them to you in a different presentation. This is still two ordered pairs. And then you still do the same steps we did from section 3.3. So that is the end of the 3.4 notes.